Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously in this course, I said that the .NET Framework class library is merely a collection of classes, each containing methods filled with functionality that we can utilize in our applications, but we didn't have to write. Microsoft has spent tens of thousands of man-hours building and maintaining this library of code, and we can benefit from it by merely calling into its classes and methods inside of our applications. Now, the framework class library is massive. Thousands of classes, each with their own set of methods. And so the developers of the framework class library wisely decided to split this library of code up into multiple files. Just imagine if you had to load the entire library into memory every time you wanted to run your application. First of all, it would be excruciatingly slow, and then secondly, it would probably take up the majority of your computer's memory. And so they split up the code into multiple files. These code files are called .NET assemblies. In fact, even the applications that we build, they're ultimately compiling into .NET assemblies. As you can see, I have a new project called Assemblies and Namespaces already open. I've added 2 lines of code. If you want to pause the video and catch up, that would be great. In lines 13 and 14, I'm merely printing hello world to the screen and then pausing the execution of the application. However, even in this application, a executable .NET assembly is being generated the very first time that we run the application while we're debugging. So now, if you want to take a look at what happens, go to your projects directory, and inside of the project folder, you'll see that there's a bin directory. We avoided this very early in this course, but now I want to talk about it briefly. The bin directory will contain both a debug and a release version, ultimately a release version. The debug version will contain additional files required by Visual Studio to connect to the execution of the compiled executable. This allows us to step through the execution and pause the execution line by line in the Visual Studio debugger. Now we can additionally then, after we've created our application and thoroughly debugged it, we can say I want to create a release version of the application, then go to Build Solution in the Build menu, and it will create a version of our application without any of those debugging symbols, without that connection to the debugger. If you look at the file system, you might be a little confused to see that it also has a lot of those extra files in there, but they're basically ignored. But that is what's going on behind the scenes. Notice that in each of these cases we're building an executable file that will run, and we could even just double click it and run the application from here like we did before, right? Now that is different from the type of .NET assembly that allows you to create a library of code that can be shared across multiple projects. In that case, you'd be compiling a project into a .dll file extension. And we can create a code library. I'll show you how to do that in another video. But at any rate, the .NET framework has to already be installed on any computer where you want your application to work or to run. Fortunately, basically every copy of Windows already has the .NET Framework runtime and the class libraries installed in a location that's globally accessible called the Global Assembly Cache. And so every .NET application can reference the same set of assemblies in that one spot on your hard drive. Now you might say that whenever you build your application and set up your application, you may not realize that by choosing to create a file new project and then selecting the console window project template, you were actually creating references to those files in the .NET Framework class library. That's one of the functions of the setup routine for a project template. So if you take a look at the references node underneath your project in the Solution Explorer over here on the right hand side, you'll see that there are some references already to these things like system, system.core, system.data, system.net, and so on. All right. Now, we'll talk about what these are in just a moment, but that's indicative of the fact that we have references into files of the .NET Framework class library that the creator of the console window application thought we might find useful at some point. All right, so we'll come back to that in just a moment. Now, sometimes you'll need an assembly from the .NET Framework class library that has not been referenced, and I'll demonstrate how to do that in an upcoming lesson. Or perhaps you need to add a reference to an assembly created by a third party, maybe even yourself. I'll demonstrate not only how to create your own class library, but then also how to create references to third-party assemblies as well. Again, there are tens of thousands of classes defined in the full .NET Framework class library. In a few cases, the same class name was used, or at least there was the potential for it to be used. And so when that happened, the creators needed a way to be able to tell one class from a different class. And so they introduced the notion of namespaces. And namespaces are like last names for your classes. So think about your name or my name, for example. Somebody might say Bob loves coffee. And you might say, well, which Bob? There's like a billion Bobs in the world, right? But if somebody were to say Robert Theron Taybor likes coffee, well, that narrows it down. I'm pretty sure that I'm the only person in the world that has that combination of first, middle, and last name, all right? So I could either use the full name, Robert Theron Taybor, to reference one person, or once we understand the context of who we're talking about, maybe we're talking about only people in this room, then you might say, well, Bob likes coffee, he's the only Bob in this room, so they must be talking about Bob, right? So the same idea works with your code. We could use the full name of the classes that we need inside of our application. So for example, the full name of the console class is actually system.console.writeLine. All right, or the system.console class, right? That's the full name of the class, and then we're calling the method in that class. However, you'll notice that I didn't have to use the word system here. Why not? Well, because we used a using statement at the very outset of this code file, which says, I want you to look inside of these namespaces whenever you find a class reference that you don't recognize. And so the C# compiler, it finds the word console and it says, I wonder where that came from. And it begins to look through the namespaces listed in the code file, and it says, oh yeah, I found a class name called console inside of a namespace called system. All right, and so it thinks, all right, well, that must be the console class that he's talking about. Now, occasionally you might have two classes with the same name and you've added using statements for each of these inside of your code file. When that happens, you merely need to disambiguate by adding the full name of the class instead of relying simply on the using statement. Now you'll notice here that by default the program.cs file has a number of different using statements. In my text editor, they're kind of faded out a little bit, which indicates to me that they're not being utilized at this moment. So we could remove unused using statements from our code and our code will compile just fine. Again, this is a convenience for us that was set up for us by whoever created the project template for a console window application. So to further illustrate this idea, let's talk about how we can go about using the .NET Framework class library to do meaningful things and how we would go about finding the source code or the classes we need to do something cool in our application. So for example, maybe I want to write data to a text file. How could I go about doing that? Well, I might open up Bing.com and I might search for, and I'm going to type in site Microsoft.com, so I'm going to limit the search results to just those that are returned by Microsoft.com. All right. This is going to help me find the documentation specifically created by Microsoft as opposed to third-party articles or whatever the case might be. So site:/Microsoft.com, and then I might just say write to a text file and then using C#, right? And so one of the top results are from msdn.microsoft.com, and MSDN stands for the Microsoft Developer Network. This is your primary source of information as a software developer on the Microsoft platform. And so in this case, here's a how-to article that will describe the code that we would need to write in order to write data to a file. Here's a long code example. In fact, it gives us 3 examples in one. And we could use one of these examples in our application in order to write data to a file. And we might decide to go ahead and use this second example. It comes close to what we want to work with here. And I copy it and paste it into my application. And I might remove some of the extra information here just because I don't need it. And I may need to modify this path. I believe I created a folder called Lesson 17 for this purpose. And notice that it's going to use a class name file and a method called writeAllText. Now in this particular case, notice that we already are given the full namespace of this file class, system.io.file. Now what we could do is actually remove that from here and go up and add a using statement for system.io, like so. All right, and notice that the compiler will find it and we'll be able to run our application. And got a little message there because I was in release mode. Let's go back to debug and start that over again. All right, and we don't get any feedback there, but if we were to open up our Lesson 17 folder, we would be able to find the text in a text file. Great. Okay, so now we can use that little snippet of code to do what we want to do. But notice it all started by searching on MSDN, finding a code snippet that we could use, and then we can modify it and add our own text here that we want to write this to our file, right? Okay, so that we can start stitching things together. So that's one thing that one way that we can find the features inside of the .NET Framework class library that we need is to search on MSDN. Let's try one more quick example, and let's go back here, back to Bing.com, and here again I want to go site:/Microsoft.com, and then I want to do C# download HTML as a string, and I might find another reference. Now this is a different style of web page. There is one web page on MSDN for every class and every method in the .NET Framework class library. So in this case we're looking at a specific page for this download string method. And if you were to look at the remarks and some of the the syntax and some of the exceptions that it would throw, what we ultimately get to is a little snippet of code that we can copy and that we can paste inside of our application. Now notice what happens this time. It does not recognize the term web client. Why not? Well, we may not have the assembly referenced in our project, or we may have the assembly referenced, but we do not have a using statement that would include the web client class. So to remedy this, I'm going to hit Control period on my keyboard, and it says that it found this class in system.net. So we can automatically add a using statement for the system.net class by merely hitting the Enter key on my keyboard, or I can just go ahead and say, let's go ahead and use the full name of the class here. I'll choose the first option using the arrow keys and then the Enter key on my keyboard. Notice what happens. It adds a using statement for system.net, and then notice that the web client class is now found. It is obviously in a different color. There's no red squiggly lines, so it looks like it found the correct class that we're looking for. Now we merely need to get it a URL, so let's try msdn.microsoft.com, like so, and then we will just write this out to screen reply. And then we might even rework our application and attempt to save that into our text file as well. All right, so let's see what we get here. Hopefully this will work. We'll run the application. All right, it took a moment, but it loaded up a bunch of HTML into our console window. We can see the closing body and the closing HTML tag. Now if we were to go back to our folder and find our lesson 17 folder and open up our text file, we see here is the full web page that we scraped off of msdn.microsoft.com. Okay, so that pretty much wraps up what I wanted to say in this lesson. We are able to utilize the classes and methods in the .NET Framework class library, and we can find what we need by doing simple searches in bing.com using site:/microsoft.com to find the classes and the methods that we want to work with. Once we find those classes that we want to work with, and we find maybe even little code snippets, we can copy those into our program, and we may need to at that point fix the references to those classes. Now in this first case, remember that it gave us the full name of our file class, system.io.file, but in the second case we had to provide the using statement system.net in order for the compiler to find the class that we were wanting to reference and work with. And ultimately we did that with hitting Control period on the keyboard to add a using statement to the very top of our code. We talked about the purpose of namespaces to provide disambiguity between class names. We talked about the using statement as a way of creating a shortcut or a context and say we're not talking about every class in the .NET Framework class library. We're only talking about the classes that happen to be in these namespaces. So if you find, Mr. C# compiler, if you find a class that you don't recognize, look in those namespaces first before you complain. Okay, so we're going to continue on these ideas in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now previously I said that the creator of the console window application project template added references to those assemblies in the .NET Framework class library that we as developers might find useful for the majority of use cases. However, if we need an assembly containing some portion of the .NET Framework class library that has not already been added to our project, then we can simply add a reference to it. So this is one of three ways that we'll demonstrate on how to add a reference to an assembly. The first being an assembly from the .NET Framework class library. Now there's a number of different ways to go about this. The easiest way, I think, is to go to the Solution Explorer and then right-click on References and select Add Reference. And here you can see there are a series of, I guess, tabs along the left-hand side that would allow us to choose from the various types of assemblies that are available to us. We want to choose the framework, and these are all of the assemblies that are part of the .NET Framework class library. All right, now and you can see that there's already check marks next to a number of the system.this, system.that system.net.http, and these contain a number of different classes, each with many methods, and these are just automatically accessible. If we needed something that is not contained here, then we could choose, for example, to just select a check mark next to the one that we want to add to our project, system.net, and click OK. And you can see that it's added a reference to system.net into our project in the Solution Explorer. Now we can reference any of the classes and utilize any of the methods in that particular assembly. Okay, so that's one way if we need to access some part of the .NET Framework class library. Now, in addition to that, there are libraries that are created both by Microsoft, and there are libraries that are created by by open source contributors, other companies that are provided for free for very specific purposes in our applications. And so these are often common features that many applications need. That's why they've been open sourced. However, they're available through a special tool called NuGet, which is a repository that's maintained by a foundation supported by Microsoft, but ultimately its own entity. All right, and so there are a number of different ways to work with NuGet in Visual Studio. I'm going to choose the visual way to do it, and I find that to be the easiest for those who are just getting started, and for me, because I'm a more visual kind of person. There's also a textual, almost command line style interface that would allow you to do similar sorts of things and even script these things. So let's go to the Tools menu and select NuGet Package Manager, and then Manage NuGet Packages for Solution. This will open up a tab. Undoubtedly, no matter what you see on my screen, it'll look different on your screen because this is going under active development for the last few years, and it has changed frequently. Now, if there were a package that we wanted to add to our solution, we could simply search for it. Typically, we can learn about these sorts of things through blog posts and what have you. Say, for example, I wanted to access a database from my console window application, and I wanted to use the Entity Framework API from Microsoft. It's available through as a NuGet package through this Manage NuGet Packages for Solution dialog. So I can select it. I can select it as one of the options. You can see it's one of the most frequently downloaded. Furthermore, I would then choose which project in my solution that I wanted to add it to, and I can choose the Install button. There's some other options as well. I'll leave you to investigate those on your own. I'm going to go ahead and click OK. I agree to the terms for using the Entity Framework. And in this particular case, it installed just a number of references to assemblies and copied them down locally to my computer. Now, depending on the type of package, it could not only contain .NET assemblies, but also sample source code files. It could actually run macros inside of Visual Studio. It could include things like style sheets and HTML, and even graphical assets that it will include your project. So this is the second way that we can go about adding assemblies and more to our projects. But the third way that I want to talk about is whenever we want to add a reference to a class library that we've created. Now, we haven't created a class library up to this point, so this is a perfect opportunity to do that and then add a reference to it in our project. So what I'll do is start off by creating a new project. Let me go ahead and let you see my entire screen here. And in the new project dialog, I want to make sure to choose C#, and then I want to choose class library. Notice that I chose the one that doesn't have the little NuGet logo next to it. It's just a little, looks like several books and the C# logo. Now this will undoubtedly look different to you, but just make sure that it's a regular old class library. And here we're going to call this my code library and click OK. And I'm going to go ahead and say I don't really care to save my other solution there. All right, and so inside of this you can see that I don't have a program.cs. All I have is a class1.cs. There's no static void main, and so what I'll call this is the scrape class. and we'll have one public method. So public string scrape web page, and we'll create a version of this where you provide it just the URL, and then we'll create a second version of this where you provide the URL and a file path. Okay. All right, and so in this first case, I'm just going to copy down some of the code that we worked with previously to create this functionality where we were actually using this web client to go out, download a page, and then save it to a text file. I'm just going to generalize this. Remember what I did previously when I hit Control period on the keyboard in order to add a reference to system.net or add a using statement for system.net. And the next thing I'm going to do here is actually replace this hard-coded string with whatever gets passed in by the end user. All right, finally, I'm also going to have to add or resolve this reference to the file class. It's in the system.io namespace, so I'm going to add a using statement for that. However, in this specific case, I'm not going to write this to a file in this overloaded version of it. In fact, what I'll just do is return whatever's been input actually downloaded from client.downloadString. All right. Now the second version, we'll do something almost identical. Here, let me replace this with URL, and we'll get rid of console.writeLine, and we'll go ahead and write this to the file path that was passed in, and then we'll return the reply. Now, truth be told, this might be a good situation where I could actually take these lines of code and create a private helper method out of them, and maybe that's a good idea. Let's do that right now. Private string get web page, all right, and we'll pass in the URL. And so here, and now both of these can just call, get web page, like so, and here we'll go string return or reply equals get web page. All right, see what I did there? How I was able to use a private helper method to encapsulate the functionality of actually getting the web page itself, and then in this case I was able to extend the scrape web page method to include writing that to an actual file path. All right. So now that I've created this, and let me go ahead and rename this file as well by right-clicking on it and selecting rename, and I'm going to choose to name this file scrape as well. I could name it anything I want. It won't matter because the name of the class itself is scrape. But at this point now, I'm going to go ahead and build the solution. It looks like it built. In fact, let me go ahead and build a release version of this. All right, great. So now let's open up a second version of Visual Studio, and I'm going to call this my client. So this will be a console application called my client, and we'll click OK. And what I want to do is to, first of all, add a reference to that DLL that we created just a moment ago. So I'm going to go and right-click on References and select Add a Reference. All right, so here I have some choices. Ideally, I would be able to look and find it in the same solution. We'll come back to that and do it in just a little bit here. But I may have to go and actually browse through the file system to find this, and unfortunately this is popping off the screen. However, hopefully we can work our way through this. And I'm going to navigate to the bin directory, into the release directory, and find my code library, and then I'm going to select the add button and then click OK. All right. And so now that I've done that, what I should be able to do is get to the scrape class, right? But it doesn't see the scrape class, so I'm going to hit Control period on my keyboard, and notice that it will find the correct using statement. The using my code library namespace, scrape, my scrape equals new scrape. Okay, and now I should be able to go my scrape dot, and there we go, scrape web page, and I should be able to give it a URL. So let's go all right, and that should return a string. So string return, or actually just value equals. All right, let's move this over a little bit. And then I should be able to print that to screen. So console.write, like so. And now we should be able to run the application. And it takes a moment, but it pops up. All right, so what we're able to do there, well, we created a reusable library now, so whenever we want to scrape a web page, we can utilize this in any of our other projects. Now, did you find how inconvenient it was to actually go and search around whenever we wanted to add a reference to it? I had to go and browse through through all my projects and everything. But I do want you to notice one thing about what happened after we did that. Let's go to my projects, and let's find that client, and let's navigate into the bin directory, and notice that it copied my code library.dll into the bin directory for the client application. So that's one of the things that it will do with any of the third-party assemblies that it will utilize. All right, but wouldn't it be easier if we were to start this over from scratch and we were to create a single solution that had both the client and the code library in the same solution? So let's do that now. I'm going to actually open up a third copy of Visual Studio. And here, let's create a new solution. So what I'm going to do is actually scroll all the way to the bottom and choose Other Project Types, and choose Visual Studio Solutions, and find Blank Solution. Now, this might be in a different place, so you may have to kind of hunt around for it, but you ultimately want to choose Blank Solution. It should be available to you. And we're going to call this Lesson 18. So the solution's name will be Lesson 18, but what we're going to do is add projects to this solution. So the first project that I'm going to add, and there's a number of ways to do this, like add, but it goes off to the right-hand side of the screen. I could add new project. File, add new project, and then we're going to choose the class library. So we'll call this the scrape library. All right, and then I'm going to choose to create another project and add it to our solution called of type console application, and this will be the scrape client. Okay. All right. So in our scrape library, what I'm going to do, just for simplicity's sake, is actually go to the work that we've done here a moment ago, and I'm going to copy all of this, like so. And let's come back here, and I want to paste all this in, like so. And yes, I'm going to have to resolve these class names by adding using statements here and here as well. All right, that should work. Looks like I actually lost my class name, so let's go public class scrape. And then let's make sure to put everything inside of it. All right, there we go. Now we get it working. And I'll rename this as well to just scrape. I could have left it, called it class 1, but that'll work just fine. Okay, so I'm going to go ahead and build that. Right-clicked on the project name and selected build. All right. And now what I want to do in the client to utilize that class library is I need to add a reference to it. So here again, I'm going to right-click and select Add Reference, and this time I'm going to go to Projects, and notice if Solution is selected, the Scrape library will be an option. I'll choose that and click OK. And now we can utilize Scrape library in our application. So let's go ahead and just type in the word scrape scrape dot, and it's not going to find it. So I'm going to hit Control period, and I need to add a using statement. Since I renamed it, now it's called Scrape Library. So I'm going to add the Scrape Library namespace to using statement to the code file. So scrape my scrape. In fact, I don't have to do all that, right? I can just copy and paste it from the previous client, like so. And we can rerun the application. Whoops. And it says a project with an output type of class library cannot be started directly. All right. Why do you suppose that happened? Well, because there are actually 2 projects now in my solution, and you can't execute a library, correct? So what we need to do is right-click on the client project and select Set as Startup Project. And now, let's go ahead and close that. When we attempt to run the application, it'll work. Furthermore, if we were to make any changes to how the library actually works, let's say, what could we do here that's interesting? Let's do this. We'll make a change in one spot. And then I'll go content plus equals, that's all folks for the very end, all right, of that string that's returned. And I'll return content this time. All right, let's make sure we add everything there. So we've made pretty big change to the application, and now when I run the application, it will recompile the DLL. It will add it to our project, and at the very end it adds that's all folks. Okay, it's just the only thing I can think of off the top of my head. All right, so hopefully now you can see that there are several different ways to add assemblies. If it's part of the .NET Framework class library, then obviously there's a way to do that. If it's a free or open source package that's available from NuGet, we can use the NuGet package manager, or we can create our own third-party class library and then add a reference to it by browsing. Or if we were to create the client and the library inside of the same solution, then we can reference it in the add reference dialog, but just under the project solution option. And we get the added benefit of being able to make updates, not having to go through 2 copies of Visual Studio to update it. It'll all be just, it'll update the next time we hit run. It'll recompile it and everything. Okay, so at any rate, that's pretty much it for this lesson. We'll continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously, we looked at arrays, which allowed us to keep a sequence or a group of related data together inside of the same variable. So we would create an array by providing a data type, and so each item in the array had to be of that data type. We would also provide the number of elements we expected in the array by defining that number between a set of square brackets. Now that we have that predefined sized array, we could add items into each element of the array or retrieve values out of each of the elements of the array by indexing into the array using a zero-based index to index in and address one specific element of the array. Now, once we had the data collected into an array, we could do some interesting things. We could iterate through the array and investigate each element of the array. Or we could even pass the array around as if it were one variable, pass it in, for example, as an input parameter to a method. But you recall at that time I also said that at some point we would talk about collections. And I even gave collections a nickname, calling them arrays on steroids, all right? And I think you're going to agree after this lesson that collections are great whenever you're working with all data types, especially those data types, those custom data types that we've been working with up to this point in this series of lessons. For example, the car class that we created ourselves. Now, as far as the .NET Framework class library is concerned, it will often use both arrays and collections depending on the need, but I think you will probably wind up preferring to use collections in your applications because of the rich filtering, sorting, and aggregation features that are available to collections through a technology, a language called LINQ, L-I-N-Q, which stands for the Language Integrated Query. It was a very innovative feature whenever it was first introduced back a number of years ago in C# and other .NET languages. Other languages have since implemented something similar to it, but we're going to dive into that topic of LINQ and what you can do with it in the very next lesson. But first of all, let's talk about collections. We're going to talk about two collections specifically, lists and dictionaries. Now, truth be told, there's probably a dozen additional varieties of collections that you could use for very specific purposes. They each have a superpower. They each have a very specific use case where they're intended to be used. I find myself using lists and dictionaries 95% of the time, so we're going to focus on those for this lesson. But after this lesson, by all means, feel free to go off and learn all of the additional collections that are available to you and what they can do that's a little bit different than the list and the dictionary. Okay, so suppose that I have a number of cars on my car lot and I want to write an application that allows me to manage them. So I need some way to collect all of the individual instances of the car class together into a single array or collection. Now again, I might use an array of cars, but I think I'm probably going to choose to use a collection because of the added features that I'm going to gain using collections. We're going to talk about a bunch of different types of collections, but I want to start off with kind of a conversation about an older style of collection that's no longer used anymore to show why there's a newer style collection that's available, and it'll help you maybe understand that idea a little bit better. As you can see, I've got a project called Working with Collections already set up here. Please take a moment and create a new console window project. I'm also going to paste in two classes that I've defined, simplified version of the car class that we've used before, and then also I'm going to create a book class, as you can see there at the bottom. Very simple classes. And the next thing that I'm going to do is actually paste in some code to actually create new instances of each of these classes and then populate their values. So you may want to pause the video yet a third time and copy in the code that I have copied to screen there as well. Alright, so the very first thing that I'm going to want to do is to work with a collection, and I'm going to work with something called an array list. And so let me just say this about array lists, that they are dynamically sized, which is one of the great benefits. You don't have to do anything to say I need to add one more item and another item and another item. Remember, with arrays, I said it was possible to resize an array, but it's a little bit of an advanced operation, not so with an array list. So that's one of the big benefits. So you can just keep adding items to it and it'll be just fine. It'll also support cool features like sorting. You can easily remove items from the collection and so on. So let's go ahead and create a new instance of this array list. And when I do, notice that we don't already have a reference or a using statement to a namespace. So what I'll have to do is hit Control period on my keyboard, and you can see that it is in a namespace called using system.collections. I'll go ahead and add that namespace to my project. And so we'll create a new one called my array list equals new array list, like so. And now that I have my array list, I can begin to add items to the array list, like for example the car, the first car, and then I can add a second car, like so. Alright. Now, one of the problems with the old style collections like the array list is that there was no easy way to actually limit the type of data that would be stored inside of the array. So for example, I want to work with automobiles, but I might accidentally add a book into the array, and it will work just fine. All right, there's no complaints. So the old style collections are not strongly typed in so much that you can put anything inside of a collection. At first glance that might seem great, but what if I wanted to actually then print out a list of all of the cars, makes, and models? So let me start by, at the very bottom here, type console.readline so we can get through that formality, and then I'm going to just do a for each. And what am I going to work with here? Let's just say I'm going to work for each car in my array list. All right, and then I might go console.writeLine, and let's just go car.make, like so. All right, and print that to screen, and let's run the application, and we will get an exception whenever we hit the third item in our array list. Notice that it has printed the first two to screen, but when we get to the book, it says that there's an invalid cast exception. In other words, we could not convert a car, or rather a book, which was the third item in the array list, into a car. So when we get to this spot in our as we're iterating through each of the items in our array list, we're going to hit a problem here. And the fundamental problem is that we allowed our collection to store something other than cars. So we cannot work with these collections in a strongly typed fashion. Now what I can do, and one of the neat features here, is that I can actually remove that item prior to going into that for each list, and we should just be able to execute the application without problem. All right, so that is at least one of the good benefits there. But unfortunately, the downsides outweigh the benefits, and so let's go ahead and take a look at the newer style collections. The first I said was that we were going to look at a list, and more correctly we're going to look at something called a generic list. So often you'll see it referred to as list of T, like so. All right, and so that of T in the term generic might require a little bit of explanation. When .NET was first released, the first set of collections allow you to put anything you wanted into them, like we saw here just a moment ago. Now, it might make sense in some contexts, but typically it doesn't, and it leads to potential errors like you saw. Now, at some point then, C# introduced the notion of generics. And specifically for our purposes, they released a series of generic collections. And so a collection is essentially generic, but it requires that you make it specific by giving it the data type that should be allowed inside of that collection. So we have a generic list, but we're going to make it a specific list to cars so that we can't even add a book to that collection. So let's attempt to do this one more time. This time we're going to go list, and notice that I'm using angle brackets, and in between the angle brackets I'm going to say what data type I want to use. In this case I want to use the car data type. So list of car called my list equals new list of car, like so. And at this point, we can go ahead and add car 1 just fine. We can add car list to my list. We can add car 2 just fine. But what happens when we attempt to add the book into our list? Well, at the point when we attempt to add the book to the list, we get an exception. We hover over and it says it cannot convert a book to a car, all right? And that makes a little bit more sense. It is specific to a car data type, so we cannot add a book to that list. But from this point on, we can work with it now with some confidence. So each car in my list. And we can just do car.model, like so. And we would get what we would expect here. Great. A list of our car models. Okay? So that's one of the big benefits of working with a generic type, is that it allows us to work with a specific data type and only allow those types into our collection. So this is probably the most popular of all of the collections available, but I'm going to show you one additional collection called a dictionary. And a dictionary is similar to, like, think of Webster's dictionary, where you have a word and you look it up in alphabetical order and find the word that you want a definition of. And then once you find the word, you can look to its right and it will have the definition. So there is a key, which is the word itself that we want to look up, and then there is the definition next to it. So there are two components to each entry in a dictionary. There's the key and then the value itself. And so typically when you see a generic dictionary mentioned, it's going to be kind of listed like this: dictionary of T key, T value. So in this case, what we'll do is specify the data type of the key. This allows us to find one specific item by the key. Now the key should be something that is unique to every entry in the dictionary. In the case of people, there might be some identifier. It could be a customer ID in your system. It could be a social security number if you're in the United States. But something that uniquely identifies one entity inside of that dictionary. And then the value can be of any data type. In the case of, again, a customer, you might have the customer ID being the key, but the customer object itself is the value that we actually want to get access to. Now in our case, this seems a little bit weak because our car class only has make and model. And we know that we could have multiple cars that have the exact same make and model. They may have different colors, they might have been created in different years, but you can have multiple cars in the car lot that have the exact same make and model. So neither of these are good candidates for keys, but there is something called a vehicle identification number. So let's go prop string, and let's call this VIN, V-I-N, that will differentiate every car in the world that's been created. So what I'll do is come back up here to the definition and go car1 VIN, and I'm just going to use a very short VIN number. I think they're typically like 18 or 24 characters long or something like that. I'm not exactly sure, but this should uniquely identify every car in the world, especially every car on our car lot. So now what I can do is create a dictionary of my cars by starting off and saying something like dictionary, and then we're going to give it the two data types. The VIN will be of type string, and then the actual value will be of type car. And we're going to call this my dictionary equals new dictionary of string car. Notice that IntelliSense helped me out by essentially giving me a lot of that, and I can just hit the semicolon at the end of the line for it to type out that entire phrase. And now that I have this, what I can do is go mydictionary.add, and we'll do car1.vin and pass in car as the actual value. So the car1vin, again, is our key into the actual car1 itself. Okay. And likewise, we'll go add car2.vin and car2. All right. And so at this point, here, if I were to attempt to find a given item, so console.writeLine, and I need to find a specific car on my car lot, I can allow a user to type in the VIN number and I can look it up in the dictionary quite easily. So say for example I want to do my dictionary dot, and then there's a number of different ways to go about this. I think probably one of the easiest ways, actually, let's go back and not use the dot. And here I'm actually going to use the key itself. So we'll call this B2. And then now we can reference a specific item in the dictionary of type car. So we can get the make, for example, and print that out to screen, like so. All right, we were able to find the geo that way. All right. All right. So hopefully that makes sense. Let's continue on. If you recall, when we originally were looking at, and let me comment all this out. We were looking at arrays. I said there's some interesting things you can do to initialize an array with values like we see here. Here we're creating a string of name, an array of strings called names, and to initialize it I give it a collection of names that are comma delimited. And so now I have an array that has 4 elements in it, and it's already been initialized with the values. You can do the same thing with the objects to initialize objects at the point of instantiation. So to do that, we'll use an object initialization syntax. In fact, let's go ahead and just to prove this all works, let's comment out everything we have up here as well. And get rid of the cars in the book. And we'll come down here and go car1 equals new car, and then notice what I do. I use that same syntax, the curly braces. And inside of here, what I can do is actually define all the values. So make equals, let's just dream large here and go make, and the model would be a 750, and we'll make it an LI, and then we'll also give it a vehicle information of C3. All right, like so. So now I've done actually 3 things in one line of code. I create a new variable called car, I create a new instance of car in the computer's memory, and now I'm getting access to that address in memory by using the car1 label, the variable name. And then I go ahead and populate the properties of the car object at the moment that I create that new instance by using this object initializer syntax. All right. Some people don't like this. It looks like it might be doing too much in one line of code, but I think you'll find that if you ever do need to hard code examples like I do frequently, that this shortened syntax actually saves you several lines of code, and it's just fine. It's valid code. All right, so let's go ahead and while we're working here, let's go ahead and create a Toyota. We'll set the model equal to a 4Runner, and we'll give that a VIN of D4. All right, like so. Okay. And so now we can work with the cars just like we did before. But in and of itself, this might not be so interesting. But this is the object initializer syntax, and we can take this one step further when it comes to working with collections. So we can use collection initializer syntax. And I want to point out one other thing, that we didn't have to use a constructor to make this work like we looked at before. That we're able to, regardless of the constructor, go ahead and set these attributes just like we use the syntax there. All right, but let's now talk about collection initializer, which can look a little hairy, but it's essentially the same thing. We're just taking it to the next level here. So in this particular case, let's go ahead and create a list of car called myList equals a new list of car. All right. Now at this point, what I can do, and notice that I put this on separate lines here. I typically might keep this on the same line just for my own sanity here. And now inside of this new empty list of cars, I can create a series of car objects like so. In fact, what I can do at this point then is use an object initializer inside of that. So here we'll go make equals Oldsmobile. And then we'll set the model equal to Cutlass Supreme. And then the VIN number, we'll set that equal to 85. Also, comma, and then we'll create another new car to add to this list of cars. And we'll set its object initializer, setting its make equal to Nissan, and its model equal to an Altima, and then finally its VIN will equal F6, something like that. Okay. And now what I've done, all in one line of code essentially, is I've created a collection and I've added 2 objects, and in each of those objects I went ahead and already initialized all of their property values. All right. Whew. So there's a lot going on there in just that one line of code. Great. So at any rate, just wanted to recap the things that we talked about in this lesson. First of all, we talked about the difference between arrays and collections, and I promised that there will be a more obvious set of features that are available to collections, which we'll learn about in the next video. We talked about the old style collections versus the new generic collections, and we said generic collections are superior because they allow us to make sure that we're only adding types, specific types to our collection. So we make a generic collection specific by passing in the data type that should be allowed to be referenced inside of that collection. Okay. Then we looked at object initializers, just a shorthand syntax for initializing the properties of a new instance of an object. And then finally taking that one step further within a collection initializer, where not only are we creating a new collection, but then initializing it with new instances of the car collection. In both of those cases, then we are using object initializers. So we can do it all on one line of code. Now, honestly, unless you're building a lot of example code like I do, you may not see this as often unless you are creating some hard-coded objects for use within your application. But I wanted you to be aware of that syntax nonetheless, because we're going to use it again in the next lesson. And we'll see you there. Thank you.